Okay, so talking about the two experiments that you're going to need to know about, talking about the two models you're going to need to know about. Cathode ray tube experiment. Okay, it was performed by a number of different people. The person who we give most credit to surrounding all of that is J.J. Thomson. Okay, and basically what they did is they had this big glass tube with electrodes running to either end and set up inside the tube. They had gas of some kind inside the tube at low pressure. And when they turned on the juice, what they noticed is that down here at the positive end of the tube, they started seeing little collisions happening, little like blinky blinks. Okay, which suggested to them that there were some particles that were inside of here that were flowing toward the positive end of the tube. So since they were flowing toward the positive end of the tube, they determined that they had to have negative charges. Furthermore, when they repeated this experiment, they found out that it was pretty much any gas would show the same results. And so the particles they found in there, first of all, they said, hey, there's negative particles that are in every substance we have here. And they have to have some kind of mass to them because later on they modified the experiment a little bit to put like a little wheel with little paddles on it. And whenever they turned this thing on, the particles flying through there would actually cause this wheel to start turning. So they had enough mass to impart momentum to the wheel and make it spin. Thomson called these little particles, my numbers here, he called these little particles electrons. They had something to do with that electric current that was going on there. Thomson then went on to come up with a model of the atom, and his model of the atom was basically, hey, you've got an atom, it's like a ball, and it's got some positive charges in it, and it's also got some negative charges in it, some of these new little electrons. But beyond that, I really don't know how they're arranged. So he just said, hey, an atom is probably a sphere-shaped, probably got positive and negative charges in it, but they're just haphazardly thrown in there, like plums in a pudding. Okay, so we nicknamed this model the plum pudding model. Now Rutherford came along not too long after that, and he set up a test to see if this was a thing. Okay? So what Rutherford did for his test, okay, we call it the gold foil experiment. He set up an apparatus where he had basically like a little cannon that was shooting, they're not a tripod here, that was shooting alpha particles, the Greek letter alpha. Okay? And this little stream of alpha particles was flying toward, I don't have yellow. Do I have yellow? But I can make yellow. Let's do this. Yeah. Was flying toward a little thin sheet of gold foil. They used gold because gold is very dense, like you saw in the video yesterday, and because since it's a metal, you can hammer it out to where it's super, super thin. It can be only a few atoms wide. And what they were testing is they were saying, well, if Thomson's model, let me just grab it real quick. Thomson's model is a thing. And what should happen is that these alpha particles are either going to all be blocked and bounce away, or they're all going to just kind of continue through. If atoms have kind of a universal density all the way throughout, okay? So they really didn't know. They were really wanting to say, okay, so how dense are these atoms? And what ended up happening, they could tell this because they put like a circular screen, and I'm going to have to do it kind of in 2 dimensions because my 3D drawing skills are not all that. They put kind of a circular screen all around it so that whenever the particles hit the screen, they would make it light up. They'd make a little blinky blinky like you had inside the tube. So what he found is that, sure, most of the blinky blinkies were happening over here where they expected them to be, if it followed kind of a straight line path all the way through. But there were a lot of other blinky blinkies, and if they had just put a thing right there and not put it anywhere else, they never would have found this out. So it was a little bit of genius move on their part to detect other places from where they expected to find things. They were finding some blinky blinkies that were up here. They were finding some that were down here. And what really freaked them out is they were finding some that were like way the heck back over here, which suggested that what these particles were doing is they were actually, some of them were actually hitting something and then bouncing off. Some other ones were being deflected at all kinds of different angles. And so what Rutherford said is that an atom like Thomson's model right here doesn't explain that. Because either they should have all been deflected or they should have all just gone straight through. Instead, what he proposed was a new model of the atom that said that, okay, so you've got a very dense, tiny, positive area of the atom, and it's filled up with mostly a region of empty space around it where your electrons are. Okay? And since he said that this very dense part in the middle, he called it the nucleus. Okay? This is what's known as the nuclear model. And it's sure not the last model of the atom. In fact, there's been 2 or 3 more. We're going to talk about another one in this upcoming unit, the one that we're kind of calling the modern model. But even to that degree, we still don't entirely understand the atom. A lot of this is just theory. Okay? We are just now developing tools that are helping us to quote-unquote see what's going on inside there. But that's the 2 experiments. That's the 2 dudes. The thing he discovered was that, hey, atoms have a nucleus. Thing that Thomson discovered is that, hey, all atoms have electrons. Okay? And that may have been more than 5 minutes, I'm not sure. Any questions? Stop the vid. Just Control K.